Names of compounds in homologous series are based on the name of basic carbon chains modified by a prefix phrase before a suffix after phrase indicating the nature of the functional group. For example, the names of alcohols taken in activity 4.2 are methanol, ethanol, propanol, and butanol. Naming a carbon compound can be done by following method. Identify the number of carbon atoms in the compound. A compound having 3 carbon atoms would have same name propane. In case a functional group is present, it is indicated in the name of the compound with earlier a prefix and suffix as given in table 4.4. In the name of functional group is to be given as a suffix. The name of carbon chain is modified by deleting the final e and adding the appropriate suffix. For example, a 3 carbon chain with a ketone group would be named in the following manner: propane E equals to propan plus 1 equals to propan 1. If the carbon chain is unsaturated, then the final NaNe in the name of carbon chain is substituted by ENE or YNE as given in table 4.4. For example, a 3 carbon chain with double bond would be called propane, and if it has a triple bond it would be called propane. Chemical properties of carbon compounds. In this section we will be studying about some of the chemical properties of the carbon compounds. Since most of the fuels we use are either carbon or its compounds, we shall first study combustion. Carbon in all its allotropic forms burns in oxygen to give carbon dioxide, along it the release of heat and light. Most carbon compounds also release a large amount of heat and light on burning. These are the oxidation reactions that you learned in the first chapter. C plus O2 equals to CO2, heat and light. CH4 plus O2, CO2 plus HO2, heat and light. CH3 CH2 OH plus 2 O2 gives us CO2 plus HO2 plus heat and light. Balance the latter two reaction like you learned in first chapter. Saturated hydrocarbons will generally give a clean flame, while unsaturated carbon compounds will give a yellow with lots of black smoke. This results in sooty deposit in metal plate in activity 4.3. However, limiting the supply of air resulting in incomplete combustion of even saturated hydrocarbons giving a sooty flame. This gas/kerosene Stove used at home has inlets for air so that a sufficiently oxygen rich mixture is burned in to give a clean blue flame. If you observe the bottoms of cooking vessels getting blackened, it means the air holes are blocked and fuel is getting wasted. Fuels such as a coal and petroleum have some amount of nitrogen and sulfur in them. Their combustion results in formation of oxides of sulfur and nitrogen, which are major pollutants in environment. Why do substances burn a with or without a flame? Have you ever observed either coal or wood fire? If not, the next time you get a chance, take a close note of what happens with wood or coal starts to burn. You have seen above the candle of or the LPG in gas stove burns with the flame. However, you will observe the coal or charcoal is an entity, sometimes just glows red and gives out heat without a flame. This is because a flame is only produced when gaseous substances burn. When wood or charcoal is ignited, the volatile substances present vaporize and burn with flame in beginning. A luminous flame is seen when the atoms of gaseous substances are heated and starts to glow. The color produced by each element is characteristic property of the element. Try and heat the copper wire in the flame of gas stove and observe its color. You have seen that incomplete conversion gives sooty with which is a carbon. On this basis, what will you attribute the yellow color of a candle flame to? Formation of coal and petroleum. Coal and petroleum have been formed from biomass which has been subjected to various biological and geological processes. Coal is the remains of trees, ferns, and other plants that lived millions of years ago. These are crushed into earth, perhaps by earthquakes or volcanic eruptions. They were pressed down by layers of earth and rock. They slowly decayed into coal. Oil and gas are the remains of millions of tiny plants and animals that live in sea. When they die, their bodies shrink to the seabed and covered by silt. Bacteria attack the dead remains, turning them into oil and gas under high pressure. They were being subjected to. Meanwhile, the silt was slowly compressed into rock. The oil and gas seeped into the porous parts of rocks and got trapped like water in a sponge. Can you guess why coal and petroleum are called fossil fuels? You have learned about oxidation reactions in the first chapter. Carbon compounds can be easily oxided on combustion. In addition to complete oxidation, we have reaction in which alcohols are converted to carboxylic acids. We have seen that some substances are capable of adding oxygen to others. These substances are known as oxidizing agents. Alkaline potassium permanganate or acidified potassium dichromate are oxidizing alcohols to acids, that is, adding oxygen to the starting material. Hence, they are known as oxidizing agents. Action reaction. Unstructured hydrocarbon add hydrogen in presence of catalysts such as palladium or nickel to give structured carbon hydrocarbon. Catalysts are substances that cause a reaction to occur or proceed to a different rate without the reaction itself being affected. This reaction is commonly used in hydrogenation or veg- of vegetable oils using a nickel catalyst. Vegetable oil generally have long unstructured carbon chains while animal fats have structured carbon chains. You must have seen advertisements stating the some vegetable oils are healthy. Animal fats generally contain structured fatty acids which are said to have harmful for health. Oil containing unstructured fatty acids should be chosen for cooking. Substitution reaction. Saturated hydrocarbons are fairly unreactive and are inert in the presence of most reagents. However, in the presence of sunlight, chlorine is added to hydrocarbon is very fast reaction. Chlorine can replace the hydrogen atom one by one. It is called a substitution reaction because one type of atom or group of atom take place of another. A number of products are usually formed with higher homologies of alkanes. Some important carbon compounds ethanol and ethonic acid. Many carbon compounds are invaluable to us, but here we shall study the properties of two commercially important compounds, ethanol and ethonic acid. Properties of ethanol. Ethanol is a liquid of room temperature referred to table 4.1 for melting and boiling point of ethanol. Ethanol is commonly called alcohol and is the active ingredient of all alcoholic drinks. In addition, because it is a good solvent, it is also used in machines such as tincture, iodine, cough syrups, and many tonics. Ethanol is also soluble in water in all proportions. Consumption of small quantities of diluted ethanol causes the drunkenness. Even though this practice is condemned, it is a socially widespread presence. However, intake of even a small quantity of pure ethanol called absolute alcohol can be lethal Also, long-term consumption of alcohol leads to many health problems. Reaction of ethanol reaction with sodium. It, alcohols react with sodium leading to evolution of hydrogen with ethanol. The other product is sodium ethoxide. Can you recall which other substances produce hydrogen on reacting with metals? Reactions to give unstructured hydrocarbon. Heating ethanol at 443 K with excess concentrated sulfuric acid results in hydration of ethanol to give ethane. The con- the concentrated sulfuric acid can be regarded as a dehydrating agent which removes water from ethanol.